Hello everyone. Today we're talking about the factors that affect the rates of chemical reactions. So we're talking about how fast a reaction goes or how slow a reaction goes, and the things that contribute to it going either fast or going really slow. So there are four main factors that are going to contribute to the rate of a chemical reaction. The first one is temperature, and then I'll just scroll down and show you the other ones. The second one is concentration. The third one is surface area. And then the last one is catalyst, so having a catalyst present. So we'll go back up and we'll talk about the first factor, which is temperature. So when you look at the rate of a chemical reaction, so in this little beaker here, we can assume that we have some sort of chemical reaction happening. So maybe it's a double replacement, maybe it's an acid-base neutralization reaction, whatever it may be. And one of these reactions is happening at 50 degrees Celsius, and the other one's at 4 degrees Celsius. You can see my nice little ice cubes in there, making that one nice and cold. So you could probably predict right off the bat which one's going to happen faster, and if you guessed this one, you are correct. So the warmer, or the higher the temperature, the faster the chemical reaction is going to be. So higher temps equal increased reaction rates. So the 50 degrees Celsius reaction is going to go faster than the 4 degree reaction because it has a higher temperature. If you wanted to slow a reaction down, you would cool it down. If you want to speed it up, you're going to heat it up. Alright, so that's the first factor that affects rate of reaction, temperature. Increased temp equals increased reaction rates. The next one is concentration. So in order to understand this one, we have to know a little bit about what concentration is. So concentration is how much solute is dissolved in a solution. So say in this chemical reaction, the beaker on the left, this one here, we've got two reactants. So the red dot, let's say that is NaCl, or sodium chloride. And then we've got the gray dots. Let's say that equals, I don't know, potassium iodide. So in this reaction, we have sodium chloride and we have potassium iodide. Okay? And in this beaker, I put in 7 grams of sodium chloride and I put in, 6 grams of potassium iodide. Okay, and I dissolved it in this amount of water, so this is going to be 60 milliliters of water. Over here we also have 60 milliliters of water, but in this beaker we have sodium chloride and we have 2 grams of sodium chloride, and our potassium iodide we have 1 gram, or let's say 1.5 or whatever, it doesn't matter. Okay, so if you're going to make a prediction, which one do you think is going to happen faster? You guessed it, it's this one. So it's beaker number 1 over here on the left. And the science 10 reason for that is that we have more molecules in this beaker here. And so the more particles that we have means they're going to be colliding more often. So if they're colliding more often, that means that they're going to react quicker. So our increased concentration is going to result in increased reaction rate. So concentration just means we have more of the solute, and in this case our solute is going to be sodium chloride and potassium iodide. So if we have more solute dissolved in solution, you're going to have a higher concentration. When you have a higher concentration, you have a higher reaction rate. So in this case we've got 7 grams and 6 grams. This one we only have 2 and 1.5. So this beaker is the one that's going to react faster. Alright, and that's the second factor that's going to affect rates of reactions. Let's move on to the third. So the third one here is called surface area. Okay, so you might be looking at this right here and thinking, what on earth is that? Well, These are sugar cubes and this is just a pile of sugar. So sugar granules. So you can think of a sugar cube, it's kind of like all of these compressed little sugar granules, and this is just a pile of sugar. So if sugar was going to being involved in a chemical reaction, you can take a look and say, well, which one do you think is going to have the faster reaction? Okay? If you guess this one over here on the right, you would be correct. And the reason for that is surface area. So these sugar cubes, they've got, you know, as many surfaces as a cube has. So they have 1, 2, 3, 4, 5, 6, 7, 8. Sorry about that. All right. So, and then we've got this pile of sugar. So each of those little sugar granules has a surface area. And then if you add up all of the surface area of all of the piles of sugar, it's going to be much, much higher than if you just calculate the surface area of all of the sides of the cube. So in other words, if you crush something up, or if you have a powdered version of something, it's going to have a faster reaction rate. So increased surface area equals increased rate of reaction, or faster reaction. One of the things that your provincial exam loves to do on this one, why does that keep happening? Oh man, no, that's not what I want. Okay, so one of the things that your provincial exam loves to do is they love to say, like, okay, and you all know how well I draw, not very well. Okay, in this little pan, you've got a cake. Okay, so you've got this little cake, it's rising it at the top of the pan. Okay, and in this, you've got muffins. It's the most unorthodox muffin tin you've ever seen, 9 instead of 12. Okay, so you take the same amount of or cake mix, and you pour it into a cake pan. You do the same thing, you take the same amount and pour it into individual little muffin tins. And it'll say, which one will bake faster? Well, the answer is the muffin tin, because it has a higher surface area. So if you break a substance into smaller pieces, you increase the surface area, which gives you faster reactions. So with surface area, increased surface area gives you faster reaction rates, and vice versa, of course. All right. The last one here is catalysts. So catalysts are substances that you add to a reaction. So they're not involved in a reaction. So say we have the decomposition of hydrogen peroxide. Okay. In order to achieve this reaction, you have to have a catalyst. So the catalyst is something that you add. Okay. That isn't involved in the reaction. So H2O2 isn't the catalyst, nor is H2 or O2. It's just something that you add in, and it will speed up the reaction rate. And it does so by lowering the activation energy. So activation energy is something you have to know about in Chemistry 11. It's not really something you have to know about in Science 10. All you have to know is that if you add a catalyst, you're going to increase the rate of reaction. So catalysts increase reaction rates. So in this little diagram I've got this little dropper that's adding an enzyme versus this one that has no enzyme. So which one's going to go faster? Pretty straightforward. It's going to be this one. And an enzyme is a biological catalyst. So I'll give you an example of an enzyme. In your mouth you have saliva, and your saliva contains an enzyme called amylase. And amylase is a catalyst or an enzyme that helps break down carbohydrates. And essentially, if you take white bread and you chew it up and you keep chewing, don't swallow it, just keep chewing it, you're going to start tasting really, really sweet sugar. Not just sweet sugar, you're going to taste sugar. And that's because the enzyme amylase actually helps break down carbohydrates into sweet tasting sugars. So that's your fun biology fact of the day, but what you need to know for Science 10 is that catalysts are going to increase reaction rates. So going back, we've got our 4 factors. One is temperature. So higher temperatures equal higher reaction rates. The next one you've got is concentration. Higher concentrations also equal higher reaction rates or faster reactions. Then you've got surface area. So increased surface area, crushing stuff up, breaking it into smaller pieces is going to give you faster reaction rates. And then catalysts. Anytime you have a catalyst or an enzyme, which is an example of a catalyst involved, you're going to have faster reaction rates. Alright, so that's pretty much it. I'm going to go home and study how many sides are in a cube. Thank you for listening. Over and out.